In this lecture, we'll learn about different types of transistor and their functions. In simplest word, we can say that transistor is a semiconductor device with three connections: collector, base, emitter, and it is capable of amplification in addition to rectification. The types of transistor are BJT and FET. In this lecture, we will discuss about BJT in detail, which is further classified into N transistor and NPN transistor, and FET is further divided into GFET and MOSFET. In this lecture, details of BJT will be discussed. BJT is a type of transistor that is commonly used in electronic circuits. BJTs consist of 3 layers of semiconductor material, with either 2 p-type layers and 1 n-type layer called a N transistor, or 2 n-type layers and 1 p-type layer called an NPN transistor. In NPN transistor, emitter and collector are made up of n-type semiconductor and base is made up of p-type semiconductor. The arrow in the symbol shows emitter and in NPN it points outward. In an NPN transistor, UCE refers to the voltage between the collector and emitter terminals, while UBE refers to the voltage between the base and emitter terminals. UCE is the voltage that determines the operating mode of the transistor. When the voltage UCE is high enough, typically a few volts, the transistor is in the saturation region, where it acts like a closed switch and allows current to flow between the collector and emitter. When the voltage UCE is low, typically a few tenths of a volt, the transistor is in the cutoff region, where it acts like an open switch and no current flows between the collector and emitter. UBE is the voltage that controls the transistor's behavior. By applying a voltage UBE to the base terminal, the transistor can be turned on or off, allowing current to flow between the collector and emitter or not. The relationship between UBE and the current flowing through the transistor is typically nonlinear, meaning that small changes in UBE can cause large changes in the collector current. In an NPN transistor, the base current, IB, controls the collector current, IC. When a small current is applied to the base terminal, it allows a larger current to flow between the collector and emitter terminals. This is because the base current controls the amount of charge carriers, electrons, and holes that can cross from the emitter to the collector regions of the transistor. As the base current increases, more charge carriers are able to cross the base region and flow from the emitter to the collector, resulting in an increase in the collector current. The relationship between IB and IC is nonlinear and is described by the transistor's current gain, also known as the beta parameter. The current gain is the ratio of the collector current to the base current, and typically ranges from 50 to 300 for a typical NPN transistor. The relationship between IB and IC can be described mathematically by the equation IC equal beta multiply IB. In a N transistor, the middle layer is made of N-type material, and the outer layers are made of P-type material. The 2 outer layers are called the emitter and collector, while the middle layer is called the base. The behavior of a N transistor is similar to that of an NPN transistor, but the direction of the current flow and voltage polarities are reversed. In a PNP transistor, current flows from the emitter to the base and then to the collector. To operate a PNP transistor, a negative voltage must be applied to the base terminal with respect to the emitter terminal. This allows a small amount of current to flow from the emitter to the base, which in turn allows a larger current to flow from the collector to the emitter.